Welcome to Geometry and welcome to a new school year. This is Mr. Zadorchak at Sweet Home High School, one of the geometry math teachers. And in this introduction to geometry, we're going to be taking a look at some basic vocabulary that we're going to be using throughout the entire year. I would say pause the video and write down these vocabulary words. They might be words that are familiar to you, but these are some basic facts that you have to know throughout the year. So why don't you begin by pausing the video and writing down these terms. Now that you've written down all these words and their definitions, let's actually see most of these words or all of these words in action. To begin with, you're going to need a sheet of paper, and we're going to look at an activity with some origami or paper folding. Grab a sheet of paper. It could even be a piece of junk mail. All you need is a rectangle. I mean, it can be just something on the back or front, that's fine, but it would be best if you have a sheet of paper that's blank on one side. And let's start off with paying attention to some of the words that you are familiar with already. What sort of shape is a piece of paper? It's a rectangle, right? It's a rectangle for what reason? Well, what makes a shape a rectangle? Well, one thing that every rectangle has that's true about it is that the opposite sides have the same length. But that's not the key ingredient for a rectangle. To be a rectangle, every corner has to be a right angle. And that's where the word rectangle comes from, right angle, or 90-degree angles. So we'll be talking more about that. So we're starting off with a rectangle, but we're going to turn this into a square. And the one way to do that would be to take the right side of the piece of paper and fold it up so that it matches the top. And you want to do a very careful job here in making sure that that side matches the top edge of your rectangle. Once you have it matching perfectly, you want to lay it flat and run your finger along this diagonal course. And now we've got this leftover piece right here, which is also another rectangle, and that's the piece that we're going to want to cut off of the piece of paper. So we're going to take this flap, this rectangular flap, and fold it over like so. And even flipping the paper upside down again, the right side up. Fold it back against itself again. This way you don't even need a pair of scissors to remove it. So it's that top flap that we want to remove. So if you have a pair of scissors, that's nice. It might make it easier to do that. But I'm just going to tear it, being very careful with the very first part of the tear, just to get it started. And then you can remove the rectangle. And you can use this as a bookmark for your English class. There you go, or social studies. All right, so we started with a rectangle, and the way it's folded up right here, obviously this is a triangle, but let's be specific. In geometry, it's always good to be specific. There are many different types of triangles. This triangle is special for two reasons. One of the reasons why it's special is because of this angle, or this opening. And you might know that that's what kind of angle? A right angle. And that makes this a right triangle. More specifically, this triangle is different than other right triangles. Yes, it has a right angle, but also has two equal sides. And that is called an isosceles triangle. It has two equal sides, and it has a right angle, so it is called a isosceles right triangle. You could also say that the angles, the base angles, are the same. The amount of opening here at the bottom of both of these two angles is identical on both sides, and that's also a feature that's true of isosceles triangles. Two equal sides and two equal angles. Let's open that up and see that we've got ourselves a square. A square is different than a rectangle because it has all four sides equal to each other, And it also has 4 right angles. So a square is a very special type of rectangle, a rectangle with all sides equal to each other. All right, folding it back up into our isosceles triangle, we're going to take this and we're going to fold it up and across like so. For you to be able to see it better, I'm just going to color this side in so you'll be able to see what I'm doing on the camera. So we're going to start with our isosceles right triangle, and we're going to grab one of the base angles and we're going to reflect it up and over like so. Now don't pin it down just yet. We don't want to make it crooked to the base of that triangle. We want to make it so that it's not crooked. And the word for that, if you remember, is the word parallel. So you want to fold that corner over, that corner piece over, so that the base is parallel to that line segment running across. And that looks pretty even. So parallel would be like railroad tracks. So make sure it's just perfect, and you want to fold that down. And now the next part's easy. We're going to take the same piece that we just folded, but on the other side, and also fold it across so that it does exactly the same thing as before. All right, so we've started with a rectangle. We turned it into a square. We turned it into an isosceles right triangle. And now we have another shape. This shape is got 5 sides. And you might be familiar with what a 5-sided object is called. It's called a pentagon. A pentagon is an example of a polygon with 5 sides. And this is different than other pentagons. This pentagon happens to be irregular. Irregular means that every single side is not the same length. So it's pretty clear to see that this is shorter than the other sides. So it's not a perfect, or it's not a regular pentagon, it's an irregular one. All right, there's just one more transformation we're going to make to the shape, is we're going to turn it into a trapezoid. To do that, we're going to take, well, you know all about kangaroos, mama kangaroos, how they have their pouch. And this may be the hardest thing to describe on the origami folding that we're doing, is you want to open up that last flap, that last arm that we made, and you see that there's like a little pouch, like so. And on the very top, you got 2 flaps. You want to take the top flap, or the top triangle, and tuck it in like a baby kangaroo going into the mama's pouch, and tuck it in so it completely disappears, and then fold it flat. Okay? And then, if you've done it correctly, then you can take that top triangle, the last flap, and fold it back against itself like so. And now you've completed the origami project. You've turned this into a trapezoid. A trapezoid has 4 sides, and there are one pair of sides, or at least one pair of sides that are parallel to each other. Now, what did you just make? Well, if you're thirsty and you don't feel like drinking out of the water fountain, you can actually fill this with water. Or if you're in the cafeteria and want to share some French fries with somebody, you can make themselves a little French fry container. Or maybe make this a Valentine for someone, for your mom for Valentine's Day, or your grandma. And you can tell her that you learned this in geometry class. All right, well, there's more to the project. And, just in the early going here, you can see that there are a lot of words that I'm using to help describe what's happening. And that's what geometry is all about, is communicating what we're seeing as we're talking about the size and shape and position of different things. So now that we know how to make this, we're going to actually tear it apart. You can always put it back together. And we're going to open it up, and we're going to take a look at the shape that we've got left. You can see that it's actually, all these folds have made certain points show up and certain segments show up. We're going to label all of these points and give them each a name. So that point at the very top, we're going to call that point A. When you're labeling with geometry, capital letters is how you label a point. And we'll call this point over here B, and this point down below C, and this point right here, point D. And those are called the vertices of the square, or the corners of the square. Now, if you did a pretty decent job with it, it looks like I did a semi-decent job, these points over here are also being formed. And we'll give those names too. We'll call that point E, point F, point G, and point H. And I see two more points along the way too. This point right here, we'll call point I, and this last point here, point J. So let's start off by talking about how these points make segments, rays, and lines. Well, let's begin with the simplest idea, which is a segment. A segment is basically a side or a row of points connecting from one endpoint to another. So an example of a segment would be segment EI. The way to write down a segment, instead of calling it segment EI, instead of actually writing all that down, we just say EI with a segment symbol above it. And there are other segments here as well. For example, FJ is also a segment. And, well, HD. Those are all examples of segments. Now, for those green segments that are there, you can actually say, based on this picture, that two of those segments are probably the same length. And if you measured it with a ruler, you might find that it's very, very close, that EI is the same length as FJ. And we can say that with an equal sign. And sometimes we actually use in geometry, or often use, a symbol called congruent. An equal sign with a little worm dancing on top of it. And that's an example of a congruent symbol, which basically says that they're an exact match. Some other examples of vocabulary that you need to know. I'll change up the color into blue. We can start talking about rays. Well, a ray starts at a point and goes all the way in one direction through another point. Another way to think of it is, in this case, in blue, I is like the sun, and it's shining a ray of light towards B, and that ray of light goes forever, in this case, towards the left. The way to write that down would not be, I guess you could write it out in words, ray, I, B, but instead of writing it that way, we like to shortcut it and write IB with a ray symbol above it. So that brings us to the last vocabulary for this slide, which is what a line is. Now, a line officially is a series of points that extends on for infinity in both directions. So in this particular design, there aren't any lines because this design is made up of a bunch of segments that have a starting point and an end point. I can actually draw a line on here by connecting points J and H, but going off the page through H, and also going off the page in that direction as well. A line is infinite, it goes on forever, and we could write out line with the words line JH, but instead of doing that, it's much cleaner and quicker just to call it JH with a decoration on top, which is a line symbol with two arrowheads. One of the last things to show you in the video is how to measure angles specifically. We can use a tool called a protractor to do this, and I suppose you have used a protractor before in your life. The way to do this, though, on the internet, in particular, and explain everything, is to have your assignment out on explain everything, like I have here, and we're going to need to actually have a protractor right there on our screen so we can measure the angles. To do that, you have to go to your browser, and it specifically has to be Google Chrome for this to work. So you go to Google Chrome and type in Math is Fun Protractor. It brings up this search result. Click on the very first one, which says Math is Fun. It gives you a picture of the protractor. You're going to click and hold down on that image of the protractor, and we're going to go to Save Image. This way you can use it on further assignments. Okay, we're going to allow it to use our photos. Before I leave that, I might as well bring up on the website the different measurements here, showing that there's 360 degrees in a circle. So this little animation shows what degree measurements look like, going all the way around in a circle. If you stop short of 90 degrees, from 0 to 90 degrees, it is an acute angle. So again, think about a monster or an animal opening up its mouth to chew on something, like a snake. It's opened up pretty wide. You can open it up as a quarter circle. That would be 90 degrees. When we see 90 degrees in a picture, often we use a square to label it. If the angle is somewhere between 90 degrees and 180 degrees, it is called an obtuse angle. If it's opened up exactly to 180 degrees, that's half of a circle. A circle is worth 360 degrees. 360 divided by 2 is 180. And if you go beyond 180 degrees, that's a word that we don't normally use in this course, but it's called a reflex angle, an angle that's more than 90 degrees. And you'll use that especially in Algebra 2 or trigonometry. And of course, if you go all the way around, it's worth 360 degrees. Well, back to our picture, and I'll show you a few measurements here. So back to explain everything. First of all, we need to get that protractor that is saved to our pictures. We need to get that onto our document. So you're going to select the addition tool there at the very top. Brings up a menu, and we're going to choose existing image or video, and that'll bring up the latest things that you downloaded, and we'll go to recently added, and it might show up as this black box here like it does on mine. Well, that's the picture that we want to include. Click done, and it puts a little mobile picture that you can move around. Now you definitely have to be focused in on the right tool. You have to be on the little finger tool here on the left menu bar to move that around. And if you want to rotate it, which you're going to have to do, you need to put 2 fingers down on that protractor and move it around. So let's measure one of these angles here. Let's go with angle B. To measure angle B, put the target of the protractor right on the vertex, and you want to rotate it so that the side, I'm going to move it and rotate it, so that the side of the protractor where it says 0 degrees is lined up with the side of the angle that you're trying to measure. Now the other side of the angle that we're trying to measure, since we're trying to measure angle B, is this side of the piece of paper, and you can see that it's stuck there at 90 degrees. So that's an example of a right angle. So angle B is worth 90 degrees. If I wanted to decorate my picture, I could put a square there to indicate that it's worth 90 degrees. Let's say we're trying to measure some of these other angles. For example, Let's say we're trying to measure angle FJD. To measure that angle, you're going to select the hand tool, slide your protractor over there, and place it just as I did right there, with the target right on letter J. And it looks like it's opening somewhere exactly between 70 and 60 degrees. So you'd refer to that as, it looks like about 65 or 66 degrees. So sometimes we will write that out, such as the measurement of angle the measurement of angle FJD is equal to about 65 degrees. We'll measure one more angle here. How about an obtuse angle? Would be like angle EID, this yellow angle here. To measure that angle, I'm going to slide my protractor right to that target point. You might have to rotate a little bit to get it lined up just right. Looks just okay. And now it's shining at about 70 degrees or 110 degrees. This is where you have to understand that this is more than 90 degrees just by the look of it. It's opened up more than a quarter of a circle. So we're not going to call that 70, we're going to call that 110 degrees. So we can write that down, that the measurement of angle EID is equal to about 110 degrees. All right, one last slide to show you with a little practice to get you ready for the assignment. This will be a good review for you to prep you for the homework. And we'll begin by looking at this first diagram here, naming all 3 points that are in the picture. So the points in the picture are R, S, and T. And that's all you have to do there. Name the only line that's in the picture. There's only one line that's in this picture actually. Do you see it? If you do, write it down. And you can abbreviate that with a line segment or a line symbol over the letters S and T. There's only one, well, there's more than one ray in the picture. It says name a ray. Well, ray has a starting point and goes forever in just one direction. So you could call that RT as an example of a ray. Or if you wanted to say S through T is also an example of a ray. Those are some examples that you could have used. Or even T through S. I'll use RT. So RT is an example of a ray. Name all 3 segments. Remember when you're labeling the segments that you want to put the segment symbol above them. So S to R is an example of one side or segment. R to T is another one. And the last one could be T to S or S to T. So 2 letters to name a segment. To name the triangle, you need 3 letters. And we're going to use a little triangle symbol to talk about this triangle that we see. And the triangle is angle RST, or triangle RST. That's one way to name the triangle. And there's a few other practice questions here at the bottom, which I think are very important. It's one of the focuses of today's introduction to you, is so that you're able to label triangles and find triangles in the picture correctly. So important practice to close things off with. And let's take a look at example A. It says label all of the parts provided in the diagram and then write all 3 ways to name the angle. So this opening right here that this is pointing to is the angle itself. It's the amount of opening that's there. These arrowheads here in blue are pointing at the sides of the angle. So those are the sides of the angle. Point E is called the vertex, or the mouth of the angle. And the three ways to call that angle out. You can call it out with one letter and an angle symbol. So that angle, that opening there, could be called angle what? Just a single letter, angle E. And if you wish, you could call it with three letters. What does that second letter have to be? The second letter has to be the vertex. So you can call it angle DEF. And the third way to call that angle out is to call it angle FED in reverse. For example B, it says to write all three ways to name the shaded angle. So the angle that's shaded right here can be labeled with, can you do it with just one letter? Well, if you tried to do it, it would be angle E. The trouble there is that there's more than one angle at point E. So calling it angle E is bad news because it could be this angle, it could be this angle, or it could be this angle. All of those are examples of angle E. There's actually three angles that have a vertex at E. So to get just the shaded one, you would have to call that angle GEH, or you could do it in reverse and call it angle HEG. And in this case, it's actually labeled with a number inside. Now that's not saying it's 1 degree, that's just the number 1. Sometimes that's placed in the picture to make it easier to call out some of these angles. So it's okay in this case to call this angle 1 because it's labeled that way. If they wanted this space right here, angle HEF, you could have also called that angle 2. So have a great day, and we'll see you either in person or on the internet later.